So you've been asked to solve simultaneous equations. Now, simultaneous equations, in a sense, is basically when you have two linear graphs and they cross over at a certain point. That is what you're trying to find. So that will have an x and y value that is the same to both graphs. So there are two methods to solving simultaneous equations. There is substitution and elimination. So let's say we have y equals 2x plus 1 and y equals 3x plus 2. Now, what is common in both of them? So for the substitution method, you can sub in points. So y equals this, but y also equals that. So this is our equation 1 and our equation 2. Now to solve these equations, we can sub them both in because they both equal the same thing. So 1 can be subbed into 2, or vice versa. So we can say 2x plus 1 equals 3x plus 2, because y equals y, and we know that y equals this, and y also equals that. Therefore, this must equal that. And now we just solve for x. So to make x a subject of the formula, I'm going to minus 2x off this side and minus 2x off this side. That should give us 1 equals x plus 2. And now I'm just going to minus 2 off this side and minus 2 off this side. And x equals negative 1. But we're not done yet. We still need to find the y value. So in order to find the y value, you can substitute this x value into this rule or this rule. So I'm just going to rewrite it. X equals negative 1. So I'll do it for both equations to show that you can use either one. So our first equation is 2x plus 1 equals y. We want our y value, and we know that x equals negative 1, so we can substitute negative 1 into our x spot. So y equals 2 times negative 1 plus 1. That will come to negative 2 plus 1. Therefore, y equals negative 1. And we can do the same thing with the other equation. It will both work. So y equals 3x plus 2. And we know that x equals negative 1. So we can substitute that into here. So y equals 3 times negative 1 plus 2. That will become negative 3 plus 2. And then y equals negative 1. So it doesn't really matter which equation you use if you're both substituting in. So these two graphs, trying to graphically show it to you what this is saying. So this graph and this graph will cross each other at negative 1 and negative 1, because x is negative 1 and y is also negative 1. So these two solutions are where these two graphs basically cut each other. So actually that's not a good one. So these two graphs are going to cut each other at this point. No. At this point here, where x is negative 1 and y also equals negative 1, this graph and this graph will cut each other at that point. Now, a second method is called the elimination method. So let's say we have x plus y equals 6, and we also have x minus y equals 10. Now, instead of substituting, we can look at both of these equations. We'll name this equation 1 and this equation 2. So basically we need to cancel out one of the unknowns, because we can't solve an equation with two unknowns. You need to cancel one of them out. So for how many unknowns you have is how many equations you're going to need to solve it. So the elimination method is basically eliminating one of these. So we could say that equation 1 plus equation 2 will give us equation 3. So if we had x plus y equals 6 plus x minus y equals 10. Now you're probably wondering, why have I done that? Well, when these two plus, it'll become 2x. When a negative and a positive plus, they'll cancel out into nothing. So we've gotten rid of one of the unknowns. And when these two plus, it'll just become 16. So by eliminating y, we can now solve for x. So we just divide each side by 2, and x equals 8. And then you can substitute this x value into either one of these equations.